Boys and girls, let's just continue from where we left off, right? So now I see that the top value is gonna cancel out with the bottom value, which is just going to leave me with what? With 1 divided by 2 to the exponent of 1, which is just 1 over 2. And therefore now I've answered the question. Since they said I must just prove that this is equal to 1 over 2. And I've shown that. So now I hope that you guys are comfortable. Hello? I hope that you guys are comfortable now with the whole thing, right? So in this problem, we are asked to simplify this, right? We're asked to simplify that. So what are we given? We're given root of 75 minus root of 50 all over root 10 minus root 5 all into root 10 plus root 5, right? So I think for this problem, it's best if in case we start off with the denominator, if we simplify this first. So what do I have? I have root 10 minus root 5, right? All into root 10 plus root 5, right? And I know because I'm multiplying two brackets, I can use the FOIL method, right? So now this is all just going to be equal to 10 uh plus root 10 times root 5, and then minus root 5 times root of 10, and then all minus 5 is all equal to 10. These two middle values are going to cancel each other out, so I have 10 minus 5, which is just equal to 5, right? So that's my numerator. So I have equal sign root of 75 minus root 50, all divided by how much? By 5, right? So now I know that for the values inside the third signs, I have to find the factors of them. So I'm going to have, let me find 75 is just equal to how much? 75, it's equal to 3 multiplied by 5 squared. And then 50, it's just going to be 2 times 5 squared, right? So let's continue. So we're going to have root of 3 multiplied by 5 squared minus root of 2 times 5 squared all over 5, right? And then you remember that I have this law. Third of A times B is just equal to the third of A times the third of B, right? So I can just have the root of 3 times root of 5 squared minus root of 2 times root of 5 squared all over 5, right? So I know I'm going to have root of 3 times what? 5, because this square root and this square are going to cancel each other, minus root 2 times what? 5, all over 5, right? And then check what I have on the numerator. I have 5 here and I have 5 there. So I can take out 5 as my what? Highest common factor. So now let me continue and do that. So when doing that, I'm going to have 5 into root 3 minus root 2 all over 5, right? And since I have multiplication sign in between here, so therefore I can say whatever is at the top can cancel out whatever is at the bottom. And then I have square root of 3 minus square root of 2. So therefore I've simplified it fully because this is just the simplest third form, right? So guys, I hope that everything is okay. So I hope that we've done the last questions, and so now we can continue. Guys, so now let's just continue. So now we're given a problem saying show that the root of x all divided by x plus y divided by root of x can be rewritten as root of x into y plus 1 all over x. So this means that we must prove that root of x all over x plus y all over root x is equal to root x into y plus 1 all over x. So we just must prove that. So I said we always take the more complicated side. So like let's take the left hand side, right? So we're gonna have root of x all over x plus y all divided by root of x, right? So guys, we have fractions, right? We're dealing with fractions. So let's remember our basic laws of fractions. Let's have a over b plus c over d. So I know in order for me to add these two things, I must first find the lowest common denominator, which in this case is just going to be b times d, right? And then once I do that, so I realize that here for this fraction, I'll be multiplying b by what? By d. So I'm gonna have b by d all as a common denominator, but then I multiply this b by a d, so I'm gonna have to multiply this a by a d also. So I'm gonna have a times d plus, now I multiply this d by a what? By a b in order for me to get this denominator. So I'm gonna have to multiply this what? By this c by also that what? That b. So I'm gonna have what? C times what? B. So that's basically what we remember doing from grade 7. So let's continue now. So here my LCD, let's first look at our, so our LCD is just going to be x times root what? X. So this is just going to be our LCD, right? So now let's continue. So we're going to have equal sign x times root x all over, sorry, dividing what? So this x, I multiplied it by what? A root x. So I'm gonna have to multiply this root x by what also? I'm gonna have to multiply it by what? By a root x. But then this root x here, I multiplied it by what? By x. So I'm gonna have to multiply this y also by what? By x. So I'm gonna have y plus y times what? X. Right? Right? So we are okay there. So check now. Check, 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 check. So now, here, I'm gonna have what? This root x times this root x is just gonna give me what? X plus y times what? X all over x times root of what? X. Right? Are we all okay? I guess we are all okay. So which is just equal to, I can just take out x as a Haskell factor for the numerators because I have I have x here and I have x there. So I'm going to have x into 1 plus y all over x times root of x, right? And then check, this x is just going to cancel that x out, and I'm going to have 1 plus y all over root x. But check, they said I must leave it as root x into y plus 1 all over x. But check, here my denominator is root x. But here I have a denominator of x. So how do they moved from what? From the root x that we have to what? To x by simply what? Rationalizing the what? The denominator. Right? So let us simply do that also. So we are going to have this. Let's continue there. So we're going to have 1 plus y all over root x times what? Root x all over root x. Right? And what is this going to give us? It's going to give us root x into 1 plus y. But then these two, when they multiply each other, we're just going to get an what? An x, which is exactly what they said they want, because it looks identical to what they said we must do, because I have a root x there and I have a root x there, and I have a 1 plus y, and there I have a y plus 1, which is still the same thing. And then I have x here, which is exactly also what they have underneath as a denominator. So guys, I think we are now done with the problem. We are now done with the problem.